I have the pleasure to present you. I work about this subject, cocoa bean classification using machine learning based on spectral meter measurement in the lab color space. The work is realized by Dr. Kacoutchy Jean, Diarra Mamadou, Abou Bakary, and Pierre Gouton. Okay. To begin, we focus on cocoa bean because Côte d'Ivoire is the world leading producer and exporter of cocoa bean, supplying around 40% of global production. Cocoa is a key export of the Ivorian economy, accounting for a significant of share of GDP and providing a livelihood for millions of people, mainly in the forest area in south and west of the country. It is economically important for our country. And our presentation is about these points. The first is objective, and after we have the motivation you have to expose, and after we have a theoretical approach used in this method to give you a method applied in our experimental experience. And the different experimental results we have, we can expose this one. And after all, we will give you conclusion. Objective: acquisition of spectrometric measurement in the lab color space to characterize the condition of cocoa bean. And we use the application of machine learning method, including SVM, random forest, and XJ, both to classify bean into fermented, poor condition, and unfermented. And after that, we evaluate the model performance using the standard classification metrics and comparison with the algorithms used in our study. As the motivation, Côte d'Ivoire is the world leading cocoa production country, which make beans quality a central economic concern. Farmers are very focused on the quality of work, and it's a reliable system for assessing cocoa bean condition can help them manage their harvest more effective and quickly identify. And after this condition, we can say that it's very important to improve the production of our cocoa bean by using automated method for helping farmers who work on traditional methods. Scientific work that we use is to contribute of the study in the development of a reliable cocoa bean classification model based on spectrum radiometric measurement to the lab color space with a comparison of SVM random forest and is able to enhance quality control in the cocoa section. For using the theoretical approach, we first use the classification of cocoa bean on the physical and chemical properties as traditional review of visual inspection of sensor evaluation. Traditionally, in machine learning, we use feature expression that here you use radiometer, which method prove useful information. They are subjective and certain and controlled. And this objective can be given by an approach using instrumental measurements such as spectroradiometry, provide reproduction and quantitative data of color and condition of cocoa bean. And after this, we focus on colorimetric aspect. And the one we choose is the lab color space, what we use in the color sense. Separated chromatic information in 3 components. L for lightness, A for the green red axis, and B for the blue zero axis. And in this theoretical approach, by the use of the lab color space, we capture suitable variable in bean coloration more accurately than RGB, CM, Ayikpa enable better detection of fermented and quality learning. And we will interest on machine learning algorithm to our work. And the method used are SVM, random forest, and XGBoost for the classification. And after this one, the color lab is very important, and we integrate spectral lab data with these machine learning methods. It becomes possible to establish a reliable and rapid classification framework of those. Okay. This approach not only improves consistency but also enable scalable in cocoa industry quality control operation. After this theoretical approach, the method we use are articulated on this step. The first one is to calibrate the spectroradiometer, and after the device is pointed in a standard while reference illuminated by a stable light source. This gives us the reference sets the white level and ensures that the outcoming measurements aren't affected by change in light or sensor variable, which are give you to the figure 1. And in the figure 2, you say that the perform method you use, we also calibrate the complete the sample of measurements. The cocoa beans are placed in the same position to have best measures, and the radiometer captures that light reflectance from the bean surface. The measurement produced in bean spectral significantly, which is then used in color analysis classification. And with the different method and step we described below, we have here a workflow or flow chart. This flowchart shows how cocoa beans were evaluated and classified. A spectroradiometer was used to capture the spectral response of the beans. From these measurements, we extracted color features in the shear lab space, specifically to the L, the A, and the B values. Each bean was assigned to class that reflects its condition. The dataset was then split into a training validation set and a test set. 3 machine learning models were trained on the extracted features, SVM, random forest, and XGBoost. On training, the model were tested to check how well they could recognize the different bean states. The final stage is used to base the model of automatically classify the condition of cocoa beans. This pipeline shows how spectral measurement and color analysis can supply the consistent quality assessment. And this flowchart is presented by the figure 4. After applying this method, we use metrics to validate our different results obtained. And the different metrics are accuracy, precision, FN score, and recall. And we obtain values presented in the table 1 for the 3 methods used. The metrics are accuracy, precision, recalls, and FN score for the 3 machine learning methods, and to ensure that the better values. And to improve again our experience, we use experimental results to validate them with a matrix, confusion matrix for the 3 methods to improve our method again. And for the conclusion, our work shows that we can use spectrometric lab color measurement with machine learning, enable reliable classification of cocoa bean fermented, poor condition, and fermented crops. And then among the tested model, SVM performed best with 94.40% accuracy, followed by random forest and XGBoost. And then the result shows that lab-based automated classification can improve consistently and objectively in cocoa quality control, making machine learning a valuable tool for post-harvest evaluation where quality to automatically critical, economically critical. And then it shows that it is an automated method to show the use of 3 things: radiometrics, machine learning method to improve the quality of cocoa in Côte d'Ivoire. Thank you for your attention, and we are waiting for your best suggestion for the improvement of our work. Thank you.